Okay, hello. We are going to be talking today about software projects that are part of the HUNCH design and prototype. And we have Steve Hellenius with us from AMES, and he's going to be talking about the projects, and he is the expert for our software projects and will be in contact with you for any questions that you might have over these projects. Okay.
Thanks, Alan. For the Hunch projects this year on the software side, we have three main projects. I'm going to go through the details of each one, kind of the requirements to watch out for, as well as what's the motivation behind them. And each of these projects touch on a different aspect of software development, and they all tackle certain problems or improvements that we could potentially build for the space station. So the first one we have here is called the Crew Personalized Mission Reminder Tool. And an overview of why this is important. Right now, crew members on the International Space Station have a mission plan. It's a very detailed plan out to 5-minute intervals of everything they need to do on a daily basis. It also has all of the crew members' activities as well as all of the activities that are kind of experiments that are going on board and everything else that's happening on the space station. So it's a lot of information, it's very detailed, and one of the motivations here is to build a tool that will allow individual crew members to see just their activities and allow them to do things like create reminders, notifications about something coming up. So that's kind of the idea here, and you'll get to use actual or you'll get to use plan data of the real format of how the mission activities are encoded on board. And the hope is if this actually gets built out and if the project is successful, we'll be able to actually read in the ISS plan data with the tool that you built. Okay, so that's kind of the overview of the tool. Let's go through the requirements. So the big one is it must be web-based. And the reason for this is that we want the astronauts to be able to pull up the tool either on their desktop or on their phone. And building a mobile app will kind of restrict it to just one device. So we want them to be able to pull it up on any of the devices they have on board. So it should be web-based. In addition, it would be great if you could design it for tablet use. And the reason for this is that most of the crew like to use tablets when they're moving back and forth on the station. So having that flexibility, and this means making sure that buttons are easily clickable when you're on a tablet device, not making things too tiny, that type of thing. That's really important for this. In addition, we'd like you to design using what's called a responsive design layout. For folks that are familiar with software development, this is a technique where you can imagine if you look at like the New York Times website on your laptop, it's laid out such that you can have a few columns of information. However, if you look at it on your mobile phone, you'll see less information per screen. But the thing to keep in mind behind the scenes is that that site and a lot of sites today are designed such that you use the same file to display that content on either a desktop or a mobile device. So I have a couple of links here to kind of go into, if you're unfamiliar with that technique, it walks through how that works and why it's important. In addition, we should, when you're building this, you want to make sure you can read in the example JSON schedule in the provided format. So JSON is a generic JavaScript object notation format. It's a very standard technique across software development for web applications. And the plan format that we're using is built on JSON. So I've provided a link of kind of like the basics of JSON. In addition to that, we have a sample file which goes over a simplified version of the plan format. And I also hope to give you a demo plan that has the amount of activities that you would expect in a real mission plan. Okay, then let's go through a couple of the use cases. We want, your app should allow the crew to see just their mission activities. And the way that you'll go about this is in the plan format that you'll get, it will have an ID of something like CDR, that stands for Commander. It might be FE1, which would mean Flight Engineer 1. So when you're looking through and reading in that format, you want to be able to filter by those IDs. In addition to that, there's a use case for having ground operators also see these activities. And in that case, it would be filtering by the activity name. So this would be like if you saw a science experiment activity, a user, whether it be a crew member or a ground operator, would be able to type in science experiment, and it would only show those items. Okay, and then the next use case is be able to create reminders, timers, or alarms for their day. So this would be like, okay, have this activity, let me set like a 10-minute timer or an alarm to notify the crew member that an activity is coming up, or a timer to let them know when it's completing, that type of thing. In terms of going about building it, I would encourage you to leverage existing frameworks. So don't reinvent the wheel. Don't feel like you need to build out your own library, that type of thing. Everything on the web, when you develop, is about leveraging the existing building blocks that have already been built and worked on by a lot of people. So as an example of that, if you wanted to show a timeline visualization, there are tools like d3.js, which allows you to easily visualize rich interactive data. There are things like jQuery for UI, which allows you to easily have cross-browser compatibility. And there are things like Bootstrap, which allows you to get a quick layout really fast for web development. And then for backend, you're free to use whatever you'd like for your backend stuff, but one area, if you're looking for a pointer, I would encourage you to use node.js. That's a JavaScript backend that would allow you to use the same language both for the front-end components and the back-end components. So that might speed up development. And then the last requirement that we have for this is you need to have something called a Marcus Baines line. And it sounds like a very minor detail, but the astronauts are really, they really love to see this line. It's a red line that marches along the timeline that shows where things currently are. I have a Wikipedia link on kind of the history between that, but that's really all it is. It's a line that marches along the activities of their day. Okay, so that's the crew personalized mission reminder tool. Okay, so now this next one, this is way different. This is using augmented reality, and specifically augmented reality to identify objects that the crew members are working on. So what's the motivation for this one? Well, when astronauts are working on experiments, so you can imagine a really complicated science experiment, they'll open up a kit bag and they have all these different parts, and they have procedures that go along with these parts that tell them, okay, this is what this part is, this is what this other part is, this is how you use it. But they're very long, and they don't necessarily have the best images in place. So it can be confusing. You can have these kind of esoteric parts that may look identical, but one's used for something very different. So the idea here is, can we use augmented reality such that when an astronaut holds up a part, it will tell them what it is. So it might be like, oh, this is the wrench for this step in the procedure, that type of thing. So this can be really useful in improving the efficiency of experiments in terms of execution. So rather than having the crew have to call down and ask what the part is, this tool might be able to tell them exactly what it is and what it's used for. Okay, so that's the motivation there, and I have a photo of kind of what you could imagine how an augmented reality interface would look. This is a commercial product where we have a HVAC technician looking at a hardware component, and they have kind of an augmented reality overlay of where the screwdriver screws need to go for that specific component. So it's stuff like that. So how do you actually build it? There are a few options. This is a really trendy field right now, so there are a lot of different ways to go about it. If you just have a regular tablet or desktop computer, there is a platform called Unity, which is used for virtual reality or augmented reality content. So that will help you build up these applications using any kind of browser or, any kind of computer device or phone device. If you have an iPad, some of the newer iPads or iPhones, which are iOS 11 or have an A9, as well as have an A9 processor, have their own technique called ARKit that can be used for that. And then the third option is if you have a HoloLens, that also has their own method for building these. I have links for each one of these frameworks. There's no requirement on using one or the other. It's kind of whatever you're comfortable with and whatever you would like to use. The requirement for identifying an object, we'd like to be able to identify it using a camera. So you can imagine if I took a picture with my phone or with my tablet, I should be able to see, I should be able to take that image and have the tool identify an object out of that. The recognition work, they can either be done through multiple images where you take an image and then have that tool train on that image. So that's where you take a bunch of photos of the tools and then it will identify it from those photos. Or you could also use an approach where you take a CAD drawing and use that as the recognition format. And the other thing I want to emphasize, even though this photo has a heads-up display, don't feel like you need to use a heads-up display. It can be a regular phone. It could be a tablet. Anything that has a camera is suitable for this. So don't feel like because it's augmented reality, it needs to be a heads-up display. Okay, so that's that product. Okay, so now this other one, this is also very different, and this is for folks that are interested in kind of the electronics, Internet of Things, RFID hardware side of software development. So this is an automatic location stowage tool, and the motivation here is keeping track of where everything is stored on board the International Space Station is very complex, and it relies on a lot of manual record keeping. So the idea here is I'd like the students to look at a prototype tagging and tracking system using either the Internet of Things, RFID, Bluetooth, or near-field communication solutions to track the location of objects and then also build a simple interface such that a crew member could use that interface to find these objects. So the requirements for this one are you have to have a user interface for the crew to use. So it can't be like a command line thing. It's got to be something that you can imagine a crew member just picks up and would be able to punch in kind of a item or a stowage locker that they're looking for, that type of thing. It has to have a minimum range of 10 feet. So we don't want a system where you have to hover over the actual item in order to detect it, because that won't be very useful when you're looking at where an item is inside the whole space station. The location information, we don't need to have it triangulate. So don't feel like you have to build some sort of GPS, indoor GPS solution. That's very difficult, and there are very large companies trying to tackle that problem. So don't feel like you need to go down that direction. And if you do, you might be able to start up your own company with that. But instead, we just want to get kind of rough direction, right? Maybe it says, oh, this item is like 1 foot away from you, 5 feet away from you, 10 feet away from you or greater. Or it could be, oh, this item is to your left or your right, that type of thing. That would be perfectly fine, and that might even be more than enough than what we would need. So because of that, you can have very coarse direction information. A really big component, however, is this needs to work in a microgravity environment. So what that means is if you're looking at a solution that uses a gyroscope or an accelerometer, you're going to want to dive into the details of that to see, will that actually work in a micro-G environment? Some of these sensors assume a standard, 9.8 meters per second acceleration in one direction. So you'll have to kind of check into that to make sure that it will work in a microgravity environment. In addition to that, the space station is a bunch of enclosed metal structures. So one of the things that comes up a lot is the RF environment. There's a lot of reflections and kind of bouncing back and forth. So I would encourage you to test out your idea in something like a metal shed or maybe a metal enclosure. That will approximate at a course level the kind of RF environment on the station. If you are going for an Internet of Things based design, so just kind of a brief thing on the Internet of Things, that's where you have a bunch of interconnected devices that can kind of conduct actions on them on their own without input from a controller. If you're going for an Internet of Things based design, I would encourage you to check out this website, which looks at the ESP8266 controller, which is this very inexpensive, very powerful Wi-Fi enabled IoT controller. And you can do a lot of cool stuff with that. And I think one of them costs about like $6 a piece. And that would be, I think, a good starting point if you want to do an IoT-based design. And that would use Wi-Fi for communication. And you can assume that you can use the station Wi-Fi for this example. Instead, if you want to go for an RFID-based design, I would check out this other resource that goes through the different types of RFID. And within that, there are decisions of, do you want to use a passive RFID design or an active RFID design? Those are all up to you. There are no requirements on that. But keep in mind that the decision to go with one of those, like a passive design versus an active design, you'll then need slightly different equipment to detect that. Yeah, so that's basically that idea, and I think that covers most of the software projects for this year.
Thank you so much, Steve. I totally appreciate your help on this, and I look forward to seeing what some of these students can do, and it's exciting to expand our program with HUNCH to include software projects. So very excited about that. Thank you so much. Really appreciate it.